So today we're going to look into the experiments regarding the rate of reactions, and this will be a small video hopefully, and this will mostly give you information that you're going to need for paper 6 and just general information that you should know regarding this chapter. So let's look into the experiment for surface area, the factor that affects rate of reaction. Let's remember that the greater the surface area, the greater the rate of reaction. They are directly proportional. Now, the apparatus that you're going to need for this experiment would be a conical flask, a balance, and cotton wool. So, conical flask. You guys do need to know the names of these for your paper 6 and paper 2, because sometimes they ask you to label apparatus, and they also ask you to label apparatus in paper 4. So really, this is very important for your IGCSE syllabus. Now, the reagents that we're going to be using is calcium carbonate and hydrochloric acid, which gives calcium chloride, water, and carbon dioxide. Now, you're going to carry out this experiment twice, so A and B. And here you're going to have large lumps. Here you're going to have finely powdered. So when you add calcium carbonate to HCl, which is in your conical flask over here. Okay. When you add calcium carbonate, the reaction that occurs releases carbon dioxide. And when carbon dioxide is released, mass decreases. And what you're going to need also with all of this is a stopwatch, of course. So you're going to measure the decrease in mass at regular time intervals. And you will plot that on a graph. For example, this is your A. So you measure at 2 seconds, you measure at 4 seconds, you measure at 6 seconds. And maybe you get something like this. Then you are going to redo this experiment with finely powdered calcium carbonate. You are once again going to measure the decrease in mass at regular time intervals. Same time intervals will give you better accuracy. And you're going to once again plot this, and you're going to get something like this. Now, since this is steeper, you can tell that this is B. It has a faster rate of reaction. Now, they might ask you why you are using cotton wool. The reason you're using cotton wool is because it allows for allows carbon dioxide to release without causing spillage of liquid. So cotton wool allows carbon dioxide to escape into the air, and it also prevents the spillage of liquid. So that is your experiment for surface area. You don't have to use calcium carbonate. Obviously, you can use any kind of carbonate, really. But this is just an example, and most likely what you will end up using, because it is easier to remember in my opinion. You can use magnesium carbonate if you want to. You're not limited to just calcium carbonate. And it doesn't matter, however, which reagent you use, because the experiment will be the same. Now let's look at concentration. Let's remember that the greater the concentration, the greater the rate of reaction. They are also directly proportional. Now, the apparatus you're going to need for this. You're going to need a flask. Actually, you know what? Let's not make it that fancy. Let's just make a normal flask. How did I? Oh, yeah. You're going to have a bung over here. Guys, this is one bung, but because I need to draw the gas syringe. Right, and you're gonna have a gas syringe here. The reagents that we're going to be using for this experiment is magnesium plus hydrochloric acid gives magnesium chloride and hydrogen gas. And obviously you're going to need a stopwatch because you are measuring the rate of reaction. The purpose of gas syringe is to measure the volume of gas. It collects gas, obviously. And since we have hydrogen, it's going to be collecting hydrogen. So you are going to carry out this experiment twice as well. So we're going to be using, let's use the letters C and D. And over here, the concentration of hydrochloric acid is half of whatever it is that you have in D. I don't have an exact value, so we'll just use X because we just need to understand the concept over here. And everything else remains the same. This is also important for the first experiment. You are only going to be changing the variable that you are experimenting. If you were experimenting with surface area, everything else needs to remain the same, as in your concentration of the acid should remain the same. Your temperature should remain the same. All other factors should remain the same. The mass of calcium carbonate that you will be using should remain the same. This is very important because what you need to measure over here is if there is any effect of surface area. So you must make sure that the mass is the same. The same thing applies here. Ensure that your temperature of acid remains the same when you perform the experiment twice. Ensure that the mass of Mg, magnesium, that you are using is the same. Alright, so it's purely simple, this experiment. What you're going to do is you're going to measure the volume at regular time intervals. And you're once again going to plot a graph you're going to get something like this for the first one and something like this for the second one. This is obviously going to be C because it's less concentrated, and this is D. So really, at the end, you're going to be comparing the slopes that you get for the graph. Now, why would you use a gas syringe? Because it's more accurate. And why the bung? Because prevent gas from escaping. We do not want the gas to escape. We don't want it to go here or here. We want it to go straight into the gas syringe so we can measure the volume and therefore get our rate of reaction. Let's look at the experiment for temperature. You are going to once again need a flask. And you're going to need a paper, a square paper with a cross on it. And what you're going to do is that you're going to place this flask on top of this paper. So I'm not sure if I can draw it. I probably can't. Okay. Well, it's not obviously the accurate drawing, but what happens is when you look Nope. Eyelashes go the other side. Whatever, this is an eye. Okay? When you look through this, you're going to be able to see the cross. It's visible because this flask is standing on top of this paper. Now, the reagents that we have over here is sodium thiosulfate plus hydrochloric acid and that gives sodium chloride plus sulfur dioxide plus water. You are not required to know this entire reaction, so don't worry about it. What you do need to know is that the flask contains sodium thiosulfate. And what you're going to do, you're going to add hydrochloric acid really quickly. And what that causes is the formation of a yellow precipitate. Yellow precipitate starts forming. And the yellow precipitate of sulfur. And it stays suspended in the liquid. With time, this yellow precipitate becomes cloudier and cloudier and cloudier, which means that when you are looking down here, so this is cloudier, cloudier, getting cloudier, you won't be able to view the crossover here. And how you are measuring the rate of reaction is the amount of time taken for the cross to disappear. And by disappear, what they mean is that you will no longer be able to view this cross because of how cloudy the precipitate has gotten. Now, how you are going to bring in the temperature factor is that you're going to repeat this experiment with the sodium thiosulfate solution pre-warmed to different temperatures. So let's say you first have the solution at 20 degrees Celsius. Then you have it at 30 degrees Celsius. Then you have it at 40 degrees Celsius. And you will notice that each time you increase the temperature, the amount of time taken for this precipitate to become cloudy and the cross disappear decreases. So it's taking 20 seconds here, it's taking 10 seconds here, and it's going to take 5 seconds here. This is not accurate data. I haven't obviously performed the experiment. We're just working with experimental values over here. So as you can see, when you increase the temperature of the solution, the reaction rate increases, the precipitate becomes cloudy faster, and the cross disappears. And that is how you can measure the rate of reaction using this experiment. And you can, once again, draw a graph. You get something like this. If you have the time here and the temperature here, so 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, and we have 20 seconds, 10 seconds, 5 seconds. And this is going to go something like this. Whoops. Not pretty, but yeah. As you increase the temperature, you need less amount of time. Now for a catalyst, it is fairly simple, and it's actually quite similar to the surface area experiment that we did. We're going to use hydrogen peroxide, which decomposes to water and oxygen. Hydrogen peroxide is a very strong, very reactive oxidizing agent. And a catalyst for this reaction that we'll be using is the manganese oxide. Now, simply, you're going to have a conical flask again, and you're going to have your gas syringe. Not pretty, but it's a gas syringe, you guys. Peroxide will be in here, and you will add finely powdered manganese oxide. You'll repeat the experiment twice. And what you will change the second time is the mass of MnO2 used. And you will see the experiment that you use the greater mass in, you'll have the greater rate of reaction. One thing that you will also notice is when you filter out the finely powdered black solid that you have here, the manganese oxide, it will remain the same mass that you had when you inserted it, because it's not taking part in the reaction. It's not taking part in the reaction. It is only speeding it up. So the mass of manganese oxide that you are using will remain constant. Alright, so once again, you're going to, for example, let's use E and F. In the first part, you used 0.5 grams. In the second part, you used 1 gram. And when you compare the volume of the gas collected, which is O2, you are collecting O2 over here at regular time intervals, you will see that the rate for F is greater than rate of E because of the amount of catalyst that you have. The catalyst in F is greater, therefore the rate of reaction increases. Alright, that's all we have for this video, and I hope this gave you information for your paper 6, mostly.